Hey guys, welcome to your notes for today. Today we're going to be talking about factoring expressions. So let's go ahead and just dive right into it. So first I want to go over some vocab. First of all, a monomial is a number, a variable, or a product of a number or one or more variables. So we have 25 here. That's a monomial. X, it's a monomial. 40x, also a monomial. But if I put an operation here besides multiplication, like x plus 4, or 40x plus 20 or 120 or 40x minus 120, those are not monomials. They're not one single term. To factor a number means to write the product of its factors. Basically, it's the opposite of doing the distributive property. I talked about two little strategies on how to do this yesterday, but we'll talk about it a little more in depth right now in case you need an extra example. The key to all of this, to all the factoring we're doing, is finding the greatest common factor. So if you need extra practice finding the greatest common factor, please practice with that before diving into factoring. So first we have two examples here. Find the greatest common factor of each pair of monomials. Well, first I'm going to break down 4x and 12x into their parts, into their factors. So when I break down 4x, well, I get that's equal to 2 times 2 times x. 12x, I can break down to 2 times 2 times 3 times x. And then you just connect all the things that are alike. So I have 2 that's alike, I have another 2 that's alike, and I have an x that's alike. I multiply all of those, and I get the greatest common factor of 4x. Another way to look at this is to look at the number first. You know that 4 divides both 4 and 12, so you pull out a 4. And then you see an x in both of them, so you pull out an x. That's more or less what we're doing here. But on larger numbers, it can be easier to just write out the factors and to break them down in their parts. So 18 here, I have 9 times 2. Well, 9 breaks down to 3 times 3, and 2 is just there. And don't forget your a. 20, we have 4 and 5. 4 can break down to 2 and 2, and 5 can't break down, times a. Well, look at that. We have 2 alike, and we have a alike. So our greatest common factor there is 2a. So that's how you can do those pretty easily. So let's take a look at what we can do with this when, let's do another example. Go ahead and pause the video. Try to do this example. All right, so let's take a look at it. So you have 12, C, and D here. Well, 12 breaks down to 4 and 3, which breaks down to 2 and 2. So you have 2 times 2 times 3, and don't forget your variables, times C times D. When I have 36... CD. 36 breaks down to 6 and 6, which is just 3 and 2, and then another 3 and 2. So we have 3 times 2 times 3 times 2 times C times D. Well, here I have a 2 that connects, another 2 that connects, a 3 that connects, a C that connects, and a D that connects. So we have 2 times 3 times C times D. Well, 2 times 2 is 4, times 3 is 12. And then we have 12CD. So 12CD is the greatest common factor for both of those monomials. Hopefully that makes sense. If you need some extra practice, please let me know. Let's take a look at using the distributive property and work backwards to express a linear expression as a product of its factors. So like I said, when we factor something, we're doing the opposite of the distributive property. So that's when it's expressed as a product of its factors. So when I have 8x and 4y, so look at 8x and look at 4y, find out what they both have in common. Well, I see that a 4 goes into both of them. You could either break them down in their factors, and you'd have 8, which breaks down to 4 and 2, and then 2 and 2, and then 4 that breaks down to 2 and 2. And you'd see that they have 2 times 2 or 4 alike. Well, that means you can pull out a 4 from both of them. But if I pull out a 4 of 8x, I still have these two and another x left over. Or sorry, not those two. I still have, I don't know why I did 8 times 2. It's just 8. So I have this 2 and this x left over. So when I pull out this 4, I'm left with 2x. When I pull out this 4, I'm left with this y. So we still have 2x plus y, as you see here, but we also pulled out that 4. It's also helpful to think of it as just dividing both of them by 4. You're dividing them both by their greatest common factor. So 8x and 4y, 8x divided by 4 is a 2x, and 4y is just a y. You can double check that you did this correctly by distributing and see what you get. See if you get what you started with, which in this case we started with 8x plus 4y. If I distribute this, I get 8x plus 4y. So I know I did it correctly, and that has to be my answer. You can re-show this with using factors, just like this example shows, so you can pause the video and read through that. You can also represent this with algebra tiles. So if I arrange these into a rectangle, I'm going to get 3 rows. So there's where my 3 is. And in each row, I have 1x, 1, 1, 1. So I have an x plus 3. And that's where we get this 3x plus 3 from when I factor 3x plus 9. Because if I look at 3x plus 9, hopefully I realize that 3 goes into both of those. So I'd factor out a 3, and I get x plus 3. And that's what this represents. Our value didn't change for this expression. We just put it in simplest form by factoring. Now sometimes you might run into an example like this, where we have a 12 and a 7, which don't have any common factors. And when this happens, you should say cannot be factored. That's our answer for when we can't find the greatest common factor. So let's go ahead and look at 3 more examples. So go ahead and try your best to factor these to the best of your ability, and we'll go ahead and go over them here in a second. So go ahead and pause the video, try to factor those to the best of your ability, and we will go over them here in a second. Alright, so 36x plus 24. Well, 36x and 24 both share the factor of 12. If I divide 36 by 12, I get, well, 3. Because 3 times 12 is 36. So I'm left with a 3x. Plus, if I divide out a 12 here, I get 2. So you get 12 and 3x plus 2. Let's say you didn't realize it was 12, though, and you took out, let's just say, a 2. If I take out a 2 here, then I'll get 18x plus 12. What you can see is that, well, 18 and 12 also share a factor. They share a factor of 6. So if I divide this by 6 and I divide this by 6 and I undo the division by multiplying by a 6 out here, well, look at that. I again get my 12, 3x plus 2. So you can factor these in steps as well, as long as you are pulling out whatever you're dividing out front and multiply it as well. When we have a 4x plus 9, well, 4 and 9 don't share any factors, so this cannot be factored. And let's take a look at that last one, where you have 14x minus a 16y. Let's go ahead and just start by taking out a 2 here. So if I take out a 2, I'll have a 7x minus an 8y. And I see that 7 and 8 don't have any common factors, so I'm done. 2 times is 7x minus an 8y is my answer. And I can double check that by distributing out and making sure I get what I started with. So So that's why it's important to fully factor. So that's why I mentioned doing it in steps here. Because if you got 2 times 18x plus 12, that is a factored form, but it's not the simplest factored form. So please keep that in mind when you're solving these problems. So make sure you take a look at what's in your parentheses still, so you make sure that it can't be factored any further. If you have any questions on this, feel free to send me an email or look at the videos I have also linked on Schoology. I hope you have a wonderful day and a wonderful weekend, and I'll see you all later. You can go ahead and work on your homework, which is page 419, number 1 through 10. And if you made it this far in the video, if you email me the word, let's go flag, then I will give you 5 points extra credit. Have a good day. I'll see you all later.